Hello everyone, welcome back to our YouTube channel. So we are back with another awesome video in our series podcast with champions. We hope you're liking our content. Please share your feedback on our comment section and don't forget to hit like and subscribe. So let's start with our today's video with our guest Arpit.
So yeah, Arpit, please introduce yourself to our audience.
So hello all. So my name is Arpit Shah. I'm currently working as a product owner and team leader, development team leader. But my past history is in testing. So I have done variety of testing throughout the years. So I have 8+ years of experience doing the hardware, software, middleware, and cloud testing. And obviously I have worn different hat like being a team leader, manager, as well as product owner. So yeah, quite a variety of experience over the years. So that's about me.
Thanks, Arpit. So let's move on to questions. So since most of your experience is into technical aspect, as in you are involved into software testing, hardware testing, or cloud testing. So let's talk about something about that. So my first question to you for that is, what is the difference between hardware testing and software testing?
So hardware, like if you're a software tester, hardware testing sounds different or sounds scary to some people. But actually, from a test concept point of view, they are no different, right? End of the day, you are testing, you have test philosophy, you have test plan, you have test strategy, and you test, right? I think where it differs is from the specialized knowledge that you have or you have to have. So for example, if you are a cloud tester, you need to know the cloud, the cloud APIs, backend, microservices, or databases, all that stuff. If you are a middleware tester, you have different skill set. If you are end-to-end tester, you have different. Same applies to hardware. If you are a hardware tester, you need to have some level of hardware knowledge. You need to again be involved upfront in the design, because in hardware, like in software, you can ask developer to add a testability aspect later, but in hardware, once it's designed, it's too late. So you have to jump in early and upfront put your requirement forward. So then when you come to testing it, you have all the facilities you need, and you need to obviously know the limitation of the component, voltage restriction, what are the things you shouldn't do, don't. I mean, I think it's pretty much same to any other software testing requirement, right? But hardware is less forgiving if you do bad things, right? So you just need to be specialized. You need to have a specialized knowledge around what you are testing, but otherwise the concept wise it's the same.
Thanks, Arpit, for that. Okay, so my next question is how to test a hardware. I'll take one example. Supposedly, Apple wants to release an iPhone, new version of iPhone. How Apple will test it, or how it should be tested?
So again, like, software has a different kind of testing. Like you have unit tests, you have functional tests, you have end-to-end tests. Hardware has the similar life cycle, right? So when the iPhone, let's say it's in the PCB level, they do the visual inspection, right? So the manufacturer of the PCB, which is the green board that where the component gets populated, they have the AOI, I think they call it. They sort of scanned it using the 3D image and just confirm that all things are looking good. They also have the basic voltage test. So what they do, they try and have a test point where the probe comes in. So they have a jig design and it knows where the test points are, and it try and energize just very limited section of the PCB and make sure the voltage outputs are as expected, which confirms that your assembly is done correctly. And there are no other issues relating to that. So I think so now the PCB level testing is done. And from that point onwards, what happens when the things get assembled, they have the assembly level test. Now, again, I won't go into detail because that's again specialized field. Then another testing which is unique to hardware is which is called Halt and Haas, right? Which is highly accelerated live testing. And then they also have another methodology. So what are those things get used for is giving warranty to customer. Because like, let's say you have a button on the hardware, you don't know how long that's going to last, but you may have expectation that over the lifespan, people going to press that button for 10,000 times, let's say. So then before even releasing the hardware, you should be able to give people warranty that my hardware is going to survive for 3 years, right? And these methodology allows you to sort of figure that out, that how the failure scenario is going to occur, and do we really need to improve it, or this button will survive 3 years. So hardware itself has its own specialized field of testing, but concept wise they are the similar.
Okay. Thanks, Arpit. I have never been involved into hardware testing, but I know a few pointers now. I know how it has been done, or how to start with hardware testing. So my last question to you is, what should be the approach for E2E testing, end-to-end testing? As we know, you have expertise in cloud testing, hardware testing, software testing. So as per your experience, how to design a good automation framework, or what components should a good automation framework contains?
So I think your question contains few different questions. So let me break it down. So I think the first question is what should be the good practices for end-to-end testing, right? Especially when hardware is involved and software is involved and cloud is involved. Now, I think if you follow the testing pyramid, right, very bottom of the pyramid is a unit testing. So you want to try and get the most coverage using the unit testing. As you go up, like unit testing, then functional testing, then end-to-end testing, or there could be even further breakdown within that depending on how many elements you got. So when you have multiple interfaces involved, you want to actually do as much as testing as you can do towards the early life cycle, which is you should focus more on unit testing, functional testing, maybe interface testing, API testing. End-to-end testing should be only considering in a complex system, especially only the business flows, right? Because debugging that complex system is hard, and then pinpointing where the fault is, because remember, when you have all these 4 components involved, the amount of team involved there is also going to be huge, right? And then when you find something, the entire circle end to end going to consume a lot of time. So the earlier you find your problem, like as long as your interface or APIs are following their contracts and it works, then you most likely be sure that your end-to-end testing business scenario is going to work. And then there will be only minor interfacing issues, which is easy to find. So when you do end-to-end testing, that should not be the testing you should focus on first. You should try and put all your energy to those other testing aspects, and then end-to-end testing should only be considering just few critical business use cases. But that's considering the complex system, right? If it is a simple system, you can just put all your energy doing end-to-end test, and that should be good enough, right?
Yep. Thanks, Arpit. Now let's move on to second part of the question, where I asked how to design a good automation framework, or what component should a good automation framework consist of.
So I think I would start by saying, first of all, people have a misconception about what framework is. I generally, all these frameworks that you hear about, I call them a runner rather than a framework. So for example, JUnit, TestNG, there are many good frameworks out there, but they are nothing but a runner. So what they do, they maintain the test case lifecycle. What I call framework is something that provides enough infrastructure that you can test something with, right? Like using that JUnit, you can't test something, right? You need to provide a test script, you need to provide infrastructure, you need to provide a specialized code that understands your system, right? You need to have the API definition, all that stuff. So all together, I call that a framework. So when you say how to design a good framework, there is no simple answer, right? Obviously, your framework has to have some minimum things, like you need to have a good logging facility. You need to have easy function calls that you can easily call. The framework needs to work for you rather than, you have to taste differently. And it needs to consider the aspect of reporting, how to produce report for management versus customer, internal report versus external report, all that good stuff. So there is a long list. I can keep going on and on about that. But I think the important part is that end of the day, the framework is designed by the person who understands the system. They use the runner, which is third party, and then they have to create an infrastructure. So that's why the good architecture mindset is important. They need to understand the requirement for that product and design framework accordingly. And I think there is no one answer, because every product is different, right? So I think that's where the experienced tester comes in, right? That's why you need a good test engineer, a good test architect. And if you don't do it correctly, it won't scale, right?
Thanks a lot, Arpit, for sharing your vast knowledge with our audience. So in the end, any last piece of advice for our audience? So our audience are the ones who basically wants to switch to manual to automation, or are the ones who are looking to start their career in automation testing?
So I think what I've been hearing lately from the test engineer is manual testing is, now becoming redundant. All I would say is every good testers I have dealt with, they have been a manual tester in past, right? Yes, adding your skill set, you can call yourself different thing. You can call yourself automation engineer or SDAT or whatever you like to call it. End of the day, you need to be good manual tester first, right? So manual testing is not going away anywhere. I can bet you that. And good manual tester have to be there in every team, at least one manual tester, right? And then of course you can have automation tester to automate few things. So that's the only piece of advice I would give, that be a good manual tester first before you try and jump into automation. Because what I am observing is when someone claims to be automation engineer, they even feel doing anything manually is bad practice, right? It's just never the case. Everything is automatable, right? Like management will say, can I 100% automate everything? Yes, everything can be automated 100%, but is it worth it? So sometimes you might want to take a business decision to keep something manual, and that means even automation testers should be doing manual testing at some point, right? And that's the only advice I would say to all engineers. Yeah.
Thanks, Arpit. So basically, don't forget the basics. Basics are very important.
Yeah, I mean, you can't call yourself tester if you have never done manual. And every automation testing also start with manual testing. So if you just
That's
jump
true.
straight into automation, then you are anyways not doing the right thing.
That's true. That's true. So in the end, thank you very much, Arpit, for sharing your knowledge.